I'm gonna send you some paperwork for the record. You have to really, yeah. I forgot to send it before. I didn't ask you, but it's okay.
You're gonna be a movie star.
Yeah. You have some posted on TikTok, okay? You have a TikTok channel?
Yeah, you see his dances. He just dances on me.
All right. Good morning, everyone. My name is Daniel. I'm a field service engineer for Ross Electric, and I'm gonna talk about the equipment that you guys see here, which is the paralleling switchgear. We have two generators that tie together into this emergency bus and provide emergency power to the ATSs right behind you. Basically, we have a brain that controls the whole system, which is inside this cabinet. Is there a way to shut that off? Or? Thank you. So this is our master control cubicle right in the middle. It has a SCADA screen, very fancy. A few meters, and I'm gonna talk about that in a second. Inside here, we're gonna have the PLC that controls pretty much everything when the system is in auto. So the critical scenarios is when we have a PLC failure, then we will have to come out here and do everything manual. And that's what we're gonna go over right now. Besides the master control cubicles, we have generator control cubicles. This is a future generator that is basically the same for all the cubicles. You're gonna find a PLC in there that is just for the generator operations. So that PLC sends outputs and receives inputs from the generator.
What's a PLC?
PLC is a programmer logic controller. So basically a computer, it has some logic built in that is gonna determine which operations the equipment that is controlling needs to do. So in the old days, it used to be relay logic. So this system is not the latest updated, but it's at least it has already some PLC logic. Then we have other kind of cubicles, which are very basic distribution breaker cubicles, which they have the breakers. These are, you guys are very familiar with them. They just send, you close the breaker, it sends power once the bus is energized. These breakers are normally closed. So if there is a load connected, you'll see the breaker close. If the breaker is not closed, you'll get an alarm, because that is not a normal condition. So you'll see this slide over here, and that's telling you, hey, there is a problem. So you come down here and it says emergency feeder open. And then if you go to your one line, you can see that that breaker changed, the status of the breaker changed to open. So basically you have to make sure that they're always closed. And you charge it. This operation will be automatically too. If the bus will be energized, it will charge on its own. Right now I have to do it manually because the bus is not energized. Then close, and then the alarm clear. And then for the generator breakers, they are normally open. This will only close when the generator is ready to go, to be connected to the bus. Okay, we'll go into that in a second. We have some filter breakers like this guy, that's why it's racked out. And then we have some empty spots for filter or for extra stuff that you guys wanna add. Then we have with this mimic panel that shows the ATS's positions. Basically, it's just getting outputs out of the PLC that will show the ATS. When the ATS is connected, in this case, we have everything in normal, right? But if we have an outage or if we have in test mode, we'll see this light turning off and this light turning on. Also, we put the ATS on bypass. We'll go over that in a few minutes. Then we'll get indications here. That's the overall of the system. Any questions so far before we get into the operation? Nope. Yeah, feel free to just raise your hand and we'll go over to your questions. So in an automatic scenario, right now the system has a master control selector switch, which always has to be an auto. Because if you turn it to manual, you get an alarm. This is not a normal condition. But also the generators will start on their own, but they will not connect to the bus on their own. So you have to be an auto in order for that to happen. Here we have a voltmeter selector switch, and once that we have something connected to the bus, we can sync around and see the different phases, the voltage in the different phases, or phase to neutral. And then we have a synchroscope. We only have one synchroscope for the whole system. And the reason why is because we want to always look at this guy when we're trying to parallel two generators together in manual. Then we have a frequency meter. Again, we only have one frequency meter in the whole system, and it's because we always want to look at this guy that is going to show us the frequency on the bus or the frequency on the incoming generator. So we can switch around that, and I'll go over that in a second. Then another couple of other meters, just for megawatts or power factor, basic information that you guys might need. And then in each generator cubicle, we have some of these meters too. 1 volts will tell us always the voltage of the generator, and we can select either phase A, B, and C, or A to ground, B to ground, C to ground, A to B, B to C, etc. We have a kilowatt meter that is going to tell us how much load is connected to that generator, or how much power is the generator providing to the system. If we only have one generator on, the full amount of load that we have connected to the bus is going to be connected to that generator. If we have more than one generator, in this case we can only have two, then the load should split in between them. We have some models that will control the load sharing, so they kind of share even. That's the idea. And you can see this when they are both connected in the kilowatt meter. You can see, oh, okay, that one 500 kilowatts, this one 500 kilowatts. Okay, we're good. If those numbers don't match, if we have like 1,000 kilowatts on one, and the other one is like 200 kilowatts, so we have a problem. And we might start getting alarms. We might start getting one of the generators might shut down. So that's always important to know where to look when you start getting some funky things. You gotta look at the gauges, see, okay, kilowatts, they look good. Amperage, if there is no load connected, what do I have amperage going on, right? There is always some chances that we get some current circulation even if we don't have a load connected. Just between the two generators is kind of normal if it's not over 5-10% of the capacity, right? But if we see like 500 amps with no load, there is a problem then, right? So in those cases, it's recommended to shut down the generator and call the generator. If it's something that is very specific for one gen, call the generator company here. Or if it's something like breaker operations, the system is not calling for the generators, something is not working here, then call Ross Electric. Okay, so we have also the amperage. I already talked about that. We got the engine selector switch. So the engine selector switch is very important because it's going to allow us to do even auto or manual operation of the generator. I'm using this as an example because this is a future cubicle, so nothing happens if I just turn it. But we're going to do a real scenario right now. So the stop reset position, that is gonna completely keep the generator and the shutdown. It's not gonna start unless somebody goes out there and start it manually at the generator. That will also reset any alarms. So if the generator is under alarm condition, the system will not see it until then. When we clear it at the generator, when we go and find the alarm and clear it, then we can come back and put it back in auto, and the alarm should clear here. If we don't clear it at the generator, we will, once we put it out of the stop reset position, we'll continue to receive the alarm here. So that's something that you guys usually do. You guys get alarms, put it in a stop reset position here, go check it out. Okay, I got a high temperature, whatever reason, it's something that I can clear. Okay, it's gone, come back, put it out of the stop reset, we're good, we don't have an alarm anymore. The auto position, the off position is the position where the generator will not run an auto, but the alarms will stay. They will not reset. So basically, a stop is like not running at all, no alarms. Off is like not running, but the alarms, if you have alarms, they will stay there. Also, for a cool down, if you put it on off, the generator has been running for a period of time, and the off position, it will go to cool down, normal 5-10 minutes, whatever you guys have set. But if you put it on the stop reset, that kills the cooldown too, so it completely shuts down the generator. The off position will not allow the generator to close to the bus. Now the auto position, that's the normal standby condition. You have the generator on auto. If everything's good, once it receives the start signal, it should start the generator, get to speed and voltage, and close the breaker. That's what we are expecting to happen, right? And then finally, when the start signal is gone, because the ATS, transfer back, whatever, or we are done with the no load test, then start signal is gone, then we keep it on auto. The generator automatically will open the breaker and it will go to cool down. After 5 or 10 minutes, whatever it says there, it will completely shut down and it will remain with no alarms. Okay? Questions so far? Maybe basic generator. Guys, can you pause it for a second? I need to pick up the. Sorry about that. So we already talked about how the generator features that we have here. Then we have the voltage adjustment and the speed adjustment here. So this is something that you guys usually don't have to deal with unless there is a very weird condition. Again, that the generator is pushing amps when it doesn't have any load. So you might want to adjust the voltage a little bit. We're gonna do that in a second. Lower, raise, very basic. Speed adjustment, same thing. If you come over here and see the frequency is like 61 hertz, then you gotta lower that frequency, otherwise it will never sync. Or you're gonna have an over frequency condition, an under frequency condition, and the system will shut down. So that's why we have this plot here. These are adjustments that we do after the PM. We make sure that the gens are at the right set points. I haven't done it. I just finished the PM Monday. I'm gonna do it in front of you guys so you guys see how that moves. And then we have the breaker close handle for close or open. This handle will allow you to close the breaker under a manual operation scenario. Well, to do that, you gotta turn on the synchroscope. We have 2 keys. It's actually one set of keys, because if I try to put this one here, it won't fit. It's only for the frequency meter switch, and then another one for the synchroscope switch. So we only have one set because we can only close one breaker at a time if we're in manual, right? So if we are closing the breaker to that bus, like it's the first generator that is gonna come online, Then as long as we have good voltage, 480, 60 hertz, generator is already running, we'll see the engine running live. We turn on the synchroscope. For the first one, you won't see a difference here, but as long as all those conditions are met, you can just close, and the breaker should close, and then you have one generator on the bus. Now, when you already have one, you're bringing the second one online, you're in the run position, generator is already running, the other gen is already connected. For this gen, I already have 480 and 60 hertz. I can check the frequency here. Remember, I told you we only have one meter. If I go to bus, I'm gonna be checking the frequency for the generator that is already connected. If I go to gen, I'm gonna be comparing the frequency with the generator that is incoming. So if all that looks good, I'll put this one on, and then I will see the synchroscope start swinging around. So the safe position to close, because this is telling me when it's on phase, is at 12 o'clock, right? So these lights will be bright if I'm like at 6 o'clock. And then it will be less bright as I get closer to 12. So when I'm at 12, these lights shouldn't be on. So when I'm doing that, I have to watch this. That's why this is a swing panel, so I can move it this way or this way. And I have to make sure that this is a 12 and then attempt to close, and then the breaker should close. If I do it over here, the system has some relay interlocks that will not allow it to close, but it's not the desired condition. Because then if that happens, if this closes like at 6 o'clock, boom, you're gonna have problems, right? But you're closing out of phase and it's gonna be really bad. So that's the basics of this. When we have a relay, a reverse power relay, the reverse power is sensing the power that is coming out of the generator. But if it senses power going back inside the generator, then it has some parameters here that it will shut down the generator, because we don't want the generator being consuming power. We want the generator be producing power, right? But there are some scenarios, if they are not in the same parameters, one generator might be producing, the other one might be consuming. So that means that instead of acting as a generator, it's acting as a motor, right? So it's getting current into it. So that's not the desired condition for the generator. So this guy will protect it, it will shut it down. And then we have an overcurrent protection relay. We only have this one in generator 2. We don't have that one in generator 1. But it's basically, as the name says, overcurrent. If we are like a super high current, it will trip the breaker and it will shut off the generator. Okay? This is just the hours meter, and then we have a test button for the, I don't see error lamp test. All right, that's the safest button you can press. Questions so far? I'm gonna go back really quick to this guy because I didn't talk about the SCADA. SCADA is this little screen that shows the one line. It tells us which breakers are closed. Red means it's closed. Green means it's open. Yellow means that it's not available. And black means that it's racked out, right? Like we have that breaker racked out. We have this filter breaker racked out, right? And then the rest of them are normally closed. And then the generator breakers, they're normally open. So when the generators are running, the breaker closed, the bus gets energized, it will turn to red. Red also means that it's energized for busing. For breakers, it means it's closed. And then the breakers will turn red. Then we have other features in the SCADA, like engine sequence. We have only 2 engines, so one has to be number 1 and one has to be number 2. This is for gen demand purposes. This is not for which one is gonna hit the bus first. No, that is something that we cannot predict. Whichever is faster is gonna hit the bus first. Then the second one is just gonna sync to it. But then we have a gen demand mode in which we don't. Usually hospitals have that mode off because the importance of the hospital loads. But A lot of places they have like a lot of capacity, probably like 7 generators, and they only need 2 to hold the whole load in the campus. So they will have a mode that the generators will automatically disconnect from the bus and go to cool down and eventually go to standby condition. So they're not running all the time during an outage. That's why we select a sequence. We want the higher number is the first one that is gonna kick off of the bus. But the first, everything comes on. The system doesn't know what's going on, so it just call for everything. Then we got cooldown timers here, fail to sync timer. Fail to sync is when we have the first generator on the bus, the second one is trying to sync, and for some reason, it's either going too fast or too slow that it can't get into sync. So we give it a 3 minutes timer to try, and if it doesn't get it, then it doesn't get it. It will go under alarm, it will shut off, and then somebody's gonna have to check what's going on. We got a low demand timer. I was talking about that. This is for removing generators out of the bus. I don't think you guys have that. Actually, the timer is super high because you only have 2 generators. So you don't want to have one out of the bus because it's only one backup. So it's better to have both connected all times. Then we got some overload and under frequency set points. That is for load shedding. The ATSs, they have set some priorities. So priority 1 is the most important load that you have, like life safety and some critical loads. Those will always transfer as soon as the first generator is online. So that priority will never shed, right? If something happens, the generator is burning out, the load will be connected still. But we have both lower priorities, like for equipment branches, like priority 2, priority 3. If we are in an overload condition, we don't have enough capacity, the system will say, okay, I'm gonna get this load out of the bus because I don't have enough capacity. I have 1,000 kW and I need to provide 1,200. So this ATS, which is for the chiller 2, I'm gonna kick it out. I don't care about the load, it's the lowest priority because I don't have enough capacity, or I'm gonna lose the generator and then I'm gonna be on the dark, right? So we have some set points for that. In this case, we only go to an overload when we are already at 100%. So the generators, if they are 1,500, they have to be at 1,500 to be considered there is overload. And then when under frequency is a very unlikely situation, but when both of the generators can reach the 60 hertz, and they are like, we have some under frequency relay internally, if they are like a 56, then it's a no-go, so it will shut off everything. And if you guys are in an outage, then you're gonna be in the dark until someone is capable to put the generators on. But that's like a catastrophe scenario. Then it shows us the priorities for all the ATSs. We can see here priority 1, 2, 1, 1, 2.1, 2.4. So whichever is different than 1, those can be removed from the emergency bus. Those can be shed out. Then and going backwards, when you are adding it, priority 1s, they are the first one that transfer. So we got the first generator online. When that breaker closes, the system sends a signal to the priority 1s to say, go. So all those ATSs transfer. And then the second one, when the second one syncs and closes, then all the priority 2 are added. And that's pretty much all you guys have on this screen. Questions so far? Alan? Lalo? Good? Okay.
I have a question.
Yes, sir.
One of our ATS is closing, like, when we do the load test, and one of them closed like maybe 2 minutes, then hopefully a long time, 1 minute or 2 minutes.
And transfers? You mean the transfer like
No,
after?
to close the breaker. So as soon as both generators synchronize and close the breaker, one of the breaker, I forgot, ATS, I forgot which one, but it closed, take a long time to close.
Okay.
So that's gonna be,
When you're talking about ATSs, there's either that they transfer to emergency or they transfer back to normal. So
transfer to emergency.
okay. So the reason why is because it's probably one of the hospital ones, right? Yeah, the hospital ATSs, they are closed transition. Closed transition means that they're gonna close the secondary source before opening the primary source. So you're going from normal to emergency, you are close to normal, closest source 2 and open source 1. It's a make before break condition. And it takes a long time because it's looking to be on sync. So we talk about syncing here between the generators. Well, those ATSs also look for in sync between utility and generator power. That's why sometimes they take a long time. Under an outage condition, when you don't have one of the sources, let's say you have an outage, you lose normal source, that one goes right away because there is only one source to go, okay? But in that case, that's why they take long. And the reason why it might be, and the other ones are not taking that long, it might be because it's not calibrated correctly, the controller. All these controllers are already outdated, so they need some calibration to get into, sometimes they're reading 58 hertz when you actually had 60 hertz. So they will take too long to transfer. But that's something that we can adjust. It's actually part of the PM. So it could be the reason. Another reason, it could be that day that the utility frequency is too high or too low. That's something that we cannot control. We control only the emergency source, right? So, but that is the reason, right? Most likely.
And Daniel, how you explained to me last time where the ones that are critical, like the life safety and the priority ones, those have already been switched, right? So there's no lag in the transfer. Will you explain that to me when we had that issue?
Yeah, I kind of remember. I think I was suggesting you to put it on open transition. So when we put it on open transition, it will do the opposite. It will disconnect from the first source, and then it will connect to the second source. So and that is not looking for in sync between generator and utility. So that will make it quicker, but you will have a little glitch in between. You know what I mean? Like these guys, they are all open transition. So if you transfer these guys, you'll hear, okay, generator power is over, boom, you see the red light there, and then you'll hear boom, boom. So it open, and then it close. And those guys, you hear a boom, that quick. It's because you don't see it, but it's close in the second source and then open in the first one. But it has a 300 milliseconds to do that. That's why you hear like so quick. But it takes a long time because it has to be in sync because it can't just do it. If it closes out of phase, you're closing out of phase between generators and utility. That will be a bad situation for the ATS, right? So trying to answer your question, it's not really a lack of the time on transferring. So the problem is people always say like, oh, this is a priority one. It should transfer within 10 seconds, right? Like this is a life safety ATS. And then you put it on test, and then it takes 5 minutes to transfer. It's like, what the hell? Well, you're putting it on test, you're not losing power. So you have both sources available. So the 10 seconds rules applies when you lose power in the normal. When you lose power, there is no closed transition operation because there is only one source to go, right? So it will call for the generator will start, and as soon as it sees emergency power, boom, boom, opens and closes, right? So when it's taking too long, it's because we have both sources available, and ATS has to make sure that they are on sync. Same thing when you are retransferring to normal for an outage, because after an outage, you already have both sources, right? You are connected still to generator, but you already have normal, and it's just timing down. So the timer gets to 0, and now it's ready to go, and then it takes another 5 minutes to transfer back. Well, the reason why sometimes it takes 20 minutes. Those 20 minutes is most likely because you have a problem with the controller. That controller has to be checked out, adjusted. A lot of times it needs to be replaced. Basically, they all need to be upgraded at some point. Unfortunately, these are all electronics, right? Especially this side. Remember the last time I came here, we have an issue that the ATS wasn't reading the voltage. These ATSs, they look for voltage, but they don't have a direct connection to the bus. They have another device that is an electronic device that is sensing the voltage, is connected to the bus, and then that one sends it through Modbus communications to the controller. So if you lose that COM loop, then the controller doesn't see it and it just doesn't work. So it's kind of a bad situation there because the newer systems, they have their controller connected straight to the bus because you want to be sensing that power, right? Back in the days, they were too afraid of connecting little electronics to 480 volts, right? So they didn't have all the new technology that they have now with the microchips and stuff. So they were afraid of frying something by putting 480 volts into the controller, so they will just use that other method. But eventually it will fail. Like everything else, right? But yeah, so that's basically the issue. It's taking too long because it's looking for NSYNC. Once it's in sync, it should transfer. Another questions? You guys good? All right. So what I want to do now, Lalo, I want to run the gens. I want you guys to see how I do the setup after the PM. And I have to do that because I haven't done it after the PM, and I in order to get it all together, I have to make sure that the parameters are set good. But I figured that it was a good idea just to have done that while you guys are here. So what I'm gonna do right now is something that you guys usually don't have to do, because I'm gonna put my meter on the back of the voltmeters, but I'm gonna be explaining you guys what I'm doing, okay? So I'm gonna start with this gen over here. You guys want to take like a 5-minute break to go to the restroom? No?
You wanna go home?
You just got here.
Books in 10th last night. So.
Oh, no. All right, I put my meter behind this voltmeter, and I'm gonna be looking for AC power. It depends on the system. I can have 120 volts or I can have up to 200 volts. So the reason why I'm doing this, I want to check the voltage and I want to check the frequency. Then I'm gonna go and do the same thing with generator 2, and I'm gonna compare those numbers. And I have to match them, kind of. If one of them is too low, I'll raise it up or I lower it down. I'll do it anyways, so you guys can see. So we're gonna run the gens. You need to notify or something? You good?
No, this is not gonna transfer.
It's not gonna transfer now. Yeah. Okay, so at this point I'm gonna run the gens manually. So that means that the breaker is not gonna close. I'm just gonna put it to run. So the engine running light is on. The engine is almost at 480. Then to check frequency, you can stay there. I turn this one to gen. And come on. Okay, give it a second. This is 200 volts. This is just for my reference, but I can switch here to hertz. I'm at 60.01, which is pretty good. So I just record those numbers for myself when I compare it with the other generator. Yeah, it seems like we have a problem with that frequency meter. It should be showing 60. All right, I'm gonna just exercise this so you guys can see how the voltage is actually increasing here and also here. This is the reason why I see 200 volts here and I see 480 over here. This is the real voltage, but this is just my reference voltage after the PTs for instrumentation. So if I increase it, it's not raising it. Okay, so it's not doing it. Are they Cummins or they're Caterpillar? The generators are Caterpillar or they're Cummins? Caterpillar. Should have no restrictions. Let's see the frequency. Okay, the frequency is working. So we're gonna have to make a note on that one, Lalo. You might wanna get that replaced. And then for the voltage, I can check at the generator because sometimes they disable that function because they don't, when the generator guy comes here, they also check this. So they don't want that to be played with. Yeah, so I'll check after to see if they disable that remote voltage adjustment. It's possible. But we are in acceptable parameters because we're at 480 and we are pretty close to 60 hertz. So I'm gonna put this back in auto. Automatically the breaker got a trip signal. You guys heard the click, but the breaker is open, so it's not doing anything. The engine light start flashing. That means that it's in cooldown. If I turn it to off, it will remain in that condition, but it will say not available, which means that if it gets a start signal, it's not gonna try to close. And then if I turn it to stop reset, then it will shut off completely. Okay. So I'll keep it like that. I'm gonna do the same thing with the other one, and then we'll start doing the fun stuff here, closing breakers and stuff. So I put it back in auto. So generator 2, it's gonna run now. You can see how the voltage is increasing until it gets to that point. See the frequency is way too high right now, so we need to adjust that. Let me see if this one shows me. Yeah, the frequency meter is jacked up. But this is why it's important after the PM, we check this. So I'm gonna set it up almost to 60.01, 60.02 is acceptable. Okay, and then the voltage should be almost the same as the other one, 200.7 was the other one. So it looks pretty good now. Again, the reason why I'm adjusting this is because I just did the PM and I know I was messing with this control, so I need to verify that everything is in a good standard set point before I run anything. It doesn't mean that it's not gonna come online, but it might take a little longer, stuff like that, right? So now we have generator 2 running. We're gonna do an automatic operation for generator 2. So engine is in the run position. If I try to close the breaker here, it should then let me, because one of the conditions is to have this synchronoscope on. And the reason why is because we don't want anybody to have the chance to attempt a closing operation without really paying attention to what we're doing, right? So if I try, it's not doing it. I turn it on. Remember, this is the first generator that is coming online, so I don't have to look at the synchronoscope. The synchronoscope is not doing anything, it's just there. So I close, the breaker closes. Now if I come here and check my one line, I see everything's red. Generator 2 is showing red because it's running and the breaker is closed. So the bus is energized. If we go to the ATS, we can see that emergency power is available at the ATS at this point. But there is no transfer because we haven't told the ATS to transfer. The ATS will only transfer if it loses power or if we tell them to transfer, right? So now we're gonna do the same thing, but on the other side, we're gonna need this handle. And we're gonna need this panel. I don't need my meter anymore, but I'm gonna put it to run. Now here we're gonna be very careful. We already have one generator on the bus. We don't wanna close the second generator to the bus unless we know that we are on phase, this way. So one thing that I gotta do is turn this key on. If I don't have that key because I forgot over there, then I can't do anything. That's why we add that condition. Only one key for all the generators, and you have to turn it on. Now when I turn it on, check the synchronoscope and the lights. So the lights are, synchronoscope is going away from 12 o'clock, and the lights are getting brighter. Right now it's going slow because they are too close in frequency. I set this one to 60.01, I set that one to 60.01. That is fine, because the system would automatically drive them to the right spot. We want it to be that close. Sometimes the people say, no, you have to raise one so it goes faster and it catch up sooner. Well, when you are in a manual condition, you want to do that, but the system is normally operating in an automatic condition, right? So you want to have it really close to 60. Right now it's at 6 o'clock, so if the system will let me to attempt closing, it will be bad, right? So if you guys are under this condition and it's super important to bring the second gen online, you can move the frequency a little bit for this guy, and look how that goes faster. You see? Now when I get to 12, look at the lights are turning off, and I close the breaker. Right at 12, I attempt to close it, and now it stays closed, right? Now I'm gonna open it, see how fast it goes. I'm gonna adjust it again. I don't have my meter, but I already know that I'm on the same parameters as the other one because it went slower. Usually this guy should tell me 60 or 6, we're gonna have to replace that. But again, I'm getting close. try how it works. Okay. Questions so far? So under a manual condition, you lose the PLC. This is the way to bring both engines online. And as long as you have it in the run position, that's very important. Keep it on the run position. You don't really need to keep this one in manual because when it loses the PLC, it's already on manual. But it's very important that you keep this in run. If these guys are not in run, you put it on auto, they will open the breaker. As soon as I turn it to auto, it opens up the breaker. Okay? So after they open the breakers are open, generators are on cooldown. You see the light flashing. If we go to the ATSs right now, we don't have any emergency power available because the breakers are open. Okay? Okay, who wants to try first?
Eddie.
Well, you were paying attention, man. That's rough.
Hey, Matt, you're on the channel. Oh, I can. Don't fuck up. So
All
none
right.
of the engines are running right now, correct?
Correct. So I'm gonna put everything under normal standby condition. Okay, so I'm gonna switch this to manual just for training purposes. So the PLC won't do anything. The only thing that is gonna happen, regardless if you're in manual or in auto, when under an outage condition, the the generators are gonna run, but they're not gonna do anything. They're not gonna close the breaker. They're not gonna send any transfer signals if you lose the PLC because the PLC is dead. So when the PLC dies, the generator is like, okay, I need to kick on because something happened. So if there is no outage, if there is no need for the generator, you can come and shut it off and have someone here to take care of the PLC. But if there is an outage, then the generators are already going to be running when you show up. Okay. So go ahead and put it on run. Let's try to close that one to the bus.
I gotta put that one in run first, though, right?
It doesn't matter. You can do either one.
I wanna. So I have to switch this to run, right?
Mm-hmm. And then you want to watch the gauges and the voltage. Make sure that you're already on a stable 480. You know what I mean?
480.
Yeah. Unfortunately, the frequency meter is not working, but we are gonna assume turn the frequency meter key.
This one?
Yeah. Turn it to bus. So we see what happened. So when he turned it to bus, nothing happened over here because he's looking at the frequency on the bus, but there is nothing connected to the bus.
Yeah.
Right. So turn it to gen, and it should show 60.
But that thing's busted.
Yeah. So we're assuming that we are on 60 hertz. Now we're good to go. Go ahead
Then
and
I'll come over and start the other one, or?
no, you can do one first because remember, if you are in an outage condition, you want to bring at least one as quick as possible, right? So finish the operation with this, and then you jump in the other one. That way, you already have all the priority ones going to emergency.
Now, what's the next step? I thought the next step was to sync. What do I gotta do to bring this up?
Well, there is nothing to sync to, right? Because right now you only have one gen.
So if I
So
want to bring, I just have to. Which one puts it on the bus? Like puts the power on the bus, I guess.
okay, so you got a breaker control here, right?
Okay.
So you want to close the breaker, you have to take it to close.
And that'll put it
Yeah.
on the bus.
Yeah, the only condition that you can try, but if this one is not on, it's not gonna do it.
Okay.
Go ahead and try.
I'll try it.
Yeah, that's it. Then
So,
turn on the synchroscope. That's like your key that enables the
So the
breaker
synchro
control.
I have to enable the synchro in order to manually put the generator
Yes.
on the bus.
Correct.
Okay. So now I close it.
Yeah. Let's go. So this is a really quick operation. Close and let go. Once you hear it closing, you let go. Because then you hold the signal and the relay, and it's a sensitive relay.
Okay.
You want to release the signal right away. Okay, so you're good over here.
We're running.
Yeah, you can check. Of course, when you do this, the ATSs are gonna transfer. ATS priority ones are gonna transfer. So you're gonna see this load increasing, right?
Right.
Okay, go ahead and do the second one. Excuse me.
And
No, you're gonna need that one. 'Cause you
I
have
gotta turn it that way, right?
yeah.
Or does it?
yeah,
Oh, I see. You already have it set up in a fancy way. Gotcha.
there you go.
So, super scope.
No, it should be easy. Then you have the wrong key. You got the frequency one. Put it on the frequency meter selector switch. There you
I gotta
go.
go grab that one too, right?
I didn't tell you because I want you,
Oh, there's one per.
one set of keys per generator.
And now I gotta turn this to off?
Yes.
Okay, so now I can turn this to off.
I'm letting you fail on these things because
I want it that way.
that's how you learn.
Yeah, I want it that way.
Yeah.
Oh, okay. So I gotta get the generator to the on position. So run. Wait till it stabilizes.
Correct.
Now that we're all stable, I can go over to my I can check the bus, which I had that generator on the bus.
Right.
Broke it. And then same thing, I can go over here, check my generator. But again, I'm busted.
Yeah.
But you already checked it. We got the 60 hertz on both minutes. This is my key, but I don't want to close it yet because I gotta do the thing where it's in the center. So to get
Exactly.
into that step,
So that key enables your breaker control, but also turns on the synchroscope. So in
Gotcha.
order to watch
so
this,
now okay, and then I close it right quick.
not until you're at 12.
That's all myself.
Yep.
How's that crumble?
That's simple, right?
Need to do it a lot, but yeah.
It's-
And then how do I shut it down?
Okay, you are already, let's think about this scenario. We lost the PLC.
Yep.
We are already with emergency power on. The next thing you're gonna do is leave this alone and go check your ATSs, right?
Right.
But we'll go into that training a little bit. So whenever you guys run through this scenario, you come here first.
Right.
Because if the generators won't start or don't close to the bus,
Then we got no power.
there is no power at the ATSs, right? So once you have both generators running and close to the bus, go back to the ATSs and start checking, okay, this one transferred, this one didn't transfer, so we go and take care of that. Okay? Questions so far? All right. Shut it off. When you go from run to auto, it's gonna open the breaker, but the generator will stay
And all
running.
of this will do automatically. I just gotta switch it to auto.
Yeah, switch it to auto, see what happens. The breaker open, generator is on cooldown. Now, go all the way to stop reset. Go to off first. Next off, yeah. Generator is not available, but it's still on cooldown. Okay, that's why you have a red light flashing
That's right, yeah.
and you have a green light flashing.
Gotcha. And then when I go to stop reset,
Go to stop reset?
cool down. Do it.
Go ahead, yeah. Now the generator is shutting off. Go ahead and do the same thing with this one. No, to trip, you don't need key. Now you're in cooldown. Now go to off. Okay, now you can go to lockout reset or stop reset, and you're off.
I could switch this to off now, right?
Yeah, always keep it on off because if not, when the generator is running, it's gonna keep the synchroscope running. Okay.
And then once,
You want to try now? Okay, go ahead. Oh,
when do I put it to auto?
I'll put it back in auto now.
Okay, when we simulate the blackout,
I'm gonna put this in auto, so the system is back in the standby condition. Yes, sir. Sorry.
we simulate the blackout, so already ATS already closed, generator run, and it had load on it. Now we got power back. The ATS automatically switching back.
Yeah. When you lose the brain here, the ATS works independently from this. So the ATS will still has its own system that it will say, oh, I have normal back, I'm gonna start timing down. Once I get to that timer, I'm gonna switch it back. But you're gonna have to come here and shut off the generators manually.
Now, we are manually overriding automatic. So we map online. Whatever the single scope right here is map. This one is map. You cannot do auto. Now you do manual. So we got the SE back online. So we have to manually switch the ATS back to SE power to get all the load before we.
Only if you have a problem at the ATS.
Oh, if it's have power, it's automatically switched.
Yeah. So the ATS has its own system, its own controller that is going to determine when to transfer back and forth. All it needs is to see power. Once the ATS is sensing normal and emergency, like right now it's sensing normal, so it's not going to do anything. Even if we apply emergency, it's smart enough to stay there because that's the preferred source, right? But if it loses power, what is it going to do? It's going to say, hey, give me power. And all it does is sends a signal to start the generators, right? So once you come, okay, you lost this, so you come here and you do what Matt did, put both engines online, then go back there. The ATS is going to be already an emergency. But if it has a problem, then you're going to have to do that manual operation at the ATS. But we're going to talk about that in a second. Okay? Normal conditions, it will be like super unlikely that we have a problem with the PLC and then also we have problem with the ATSs. You know what I mean? They are independent. Okay? Questions? But it's a good question. Anybody else wants to try before we move on to the ATSs? Okay. So the system is in auto. We already checked the generators. Oh, let me just do a quick auto operation. So there is a no-load test button. Do you guys use that? No-load test?
Yeah,
For monthly test?
yeah. Every other week we do no load and then.
Okay, and you started from here?
We start either load or no load, load or no load.
Okay. For the no-load, you started from here?
Yes, yes.
Okay, so you guys already know about the no-load test. Okay, so for those that don't know, the system also has some features here that allow you to do no-load test. No-load test means nothing's gonna transfer. It's just automatically gonna bring both generators online. Basically what he did right now is gonna do it on its own, right? So I'm gonna hit that button so you guys see how this start, one hits the bus, the other one syncs, and then it's good to go, and then we end the test, okay? So I think he asked for a password, right? You guys have to log in.
Yes. The key on top.
You see, you know the system better than me. It's 3020?
2030.
2030. Yeah. This one? Yes. Okay.
Okay, no.
So I press no load test and let's see what happens.
Oh, I'm sorry, password 3020.
It's okay.
My fault.
Oh no, you're good.
So enter the password again, 3020.
So generators are running. This one hit first. So now that one takes a little longer because it's trying to sync, right? But we don't see that. We could if we were fast enough to bring this here. I wasn't, but I can do it again. I'm gonna put it back in auto and we can watch syncing there. It's doing what you did, but automatically. 12 o'clock, close it. You see how in this case it was going backwards? You know why?
It's automatic and does what it wants.
Because it's driving it, right? So regardless of the frequency, we're at 60.1, the system says, hey, no, lower the frequency and come back because I need you as soon as possible, right? Same thing over here. I want to see how quick the other one is to sync. I can kick this out of the bus, turn the synchro scope, and I'm gonna let it go a little further before I try to bring it back. So right now it's going clockwise, right? But you see how fast it brought it back? Then to end the no-load test, we just press the button again. Breaker, both of the breakers open, general sudden cool down. That's it. Now, because we don't have load, we were not running the generators for so long, I'm just gonna shut it off. There is no reason to have it running. I know you guys have to do paperwork for that. All right, any questions? That's it, guys, for switchgear. We go to the ATSs really quick.